All right, so in Algebra 1, you guys used set builder notation. Does anybody remember? So your set builder notation kind of looked like those squiggly brackets. Maybe something like x such that x was greater than 3. So that would mean like your x values were larger than 3. So what we're going to use while we're in Algebra 2 is we're going to be using interval notation. So we have two types of brackets that we'll be using. We have our square bracket, and then which is this guy here, and we also have our round bracket, kind of like your parentheses. So the difference between them is when you see square bracket, you kind of want to think when you would use like your less than or equal to, or like your greater than or equal to. So think about when you graph that on a number line, those two symbols use what for that circle? Anybody remember? Yep.
It's like a filled in.
Yeah, you're filled in, that closed circle. So kind of think you have that closed circle if you were using it on a number line. And then your round bracket, those parentheses, those are kind of going to be like when you would be using your like less than or greater than symbol. And then what would that look like on a number line? Yeah, your open circle. So let's take a second and just on this number line below. So let's think, we are going to be having our interval from -1 to 8. So let's just first think, at -1, what type of circle would we be having? Closed, right, so that's going to be that filled-in circle. And then, thinking about at 8, what type of circle would we have? Open, right. So kind of note that this is kind of like your lower bound, -1, and 8's kind of like your upper bound. So what that means is this interval is everything in between. So all of these values between represent that interval. So thinking like values that would work in here, like 0, 2, 3, 3.5. So thinking about, does -1, is -1 included in this interval?
Yes.
Yes, because you have that closed circle there. What about at 8? Is 8 included in the interval?
No.
No, but like 7.9999999 would be included. Like you're getting as close to 8 as you can without actually including 8. So that's just a little basics of some notation we're going to be using. So what happens if there is no endpoint? So we have our endpoints here. Does anybody remember that term back from Algebra 1 where you kind of took on all the values? Yeah, all real numbers. So kind of think if you want to say like all real numbers. So if we're using all real numbers, that means we're going all the way left, which is kind of what value? Yeah, we're going all the way from like -infinity, and then we would be going all the way to your positive infinity. So note if you want to say all real numbers with your interval notation, that would be your parenthesis, -infinity to positive infinity. So think about why we're going to be using parentheses there and not those square brackets. Can I physically put a point on positive infinity and say, yes, I'm including that? No, so that's why we're using those parentheses here. So just note that when you're using or talking about your positive and negative infinity, those are always going to be your parentheses. So remember what that would look like with your set notation. You have your squiggly bracket, x such that x is all real numbers. Did you have a question? Oh, I'm so sorry. Sorry, I was picking it up. Somebody walked in a sec late. All right, so let's look at a couple of these down here. So thinking about our interval notation, let's just look at the first one. We'll do like two together, and then you guys can do the rest on your own. So looking at your first one, kind of think about your interval notation. What is going to be like our first value, that like lower bound? 5. What type of bracket should we have? Yes, a square bracket at 5. And then I go all the way to when? 7 with a, there we go. So think about if you want to kind of relate it back to your set notation. It would be like 5 less than or equal to x less than or equal to 7. So let's do this second from the bottom one here. So what's kind of that like lower bound, that like first value you have? Yeah, negative infinity. So thinking about this arrow here, this is going to keep going left and left and left and left and left forever. So I think that means I'm going to negative infinity. And when I use negative infinity, what brackets do I have? The parentheses, yeah. So negative infinity to 6 with a square bracket. And then thinking about our notation with our set. So think about these are all your x values that are going to be less than or equal to 6. So why don't you guys take a sec, finish those next 3 on your own, and then we can check back in. All right, so let's go back through these. So this first table right here, do you guys want to help us fill in this second one here? Sorry, I'm still learning everyone's names.
For the interval notation, it's a square bracket and 5, and a 7 with the parentheses.
Okay. So we can call that also like your open bracket too.
And for the set notation, it's a squiggly one, and 5 is less than or equal to x is less than 7.
Okay. All right, Grace, you want to help us out with the next one?
The next one is parentheses or open bracket with 5, and then 7's in another open bracket. And then it's squiggly, 5 is less than x, which is less than 7.
All right, and then last one. What's a parentheses? Want to see what you say after that? Sorry. So let's think. You always start with your smallest value first. So this is a good point. So thinking about your smallest value, like read your graphs always left to right. So that's what we're going to be doing a lot today, left to right. So starting all the way left, what's that first value you have? 2, good. And then you go all the way until, good, with your parenthesis open bracket. So that would just be that your x is greater than 2. All right, so that's just kind of some basic info. So let's keep moving on. So to that other side of your first page. So what happens if there's more than 2 intervals? So in our example below, see how we have 2 intervals? Remember, if you can think back to Algebra 1, that would be kind of like your OR statements. Like here, we would say x is less than -4, or x is like, and then if this like went on that way, you would say or x is greater than 1. Remember, they would kind of like have arrows opening up to them. So in Algebra 2, we're going to use a capital U. So that stands for your union. So let's look at this example here. So remember, we're always going left to right. So all the way from the left, what's this like first value if we have an arrow here? Yeah, so we have negative infinity to where? -4 with a open. And then I have to continue on, so I'm using that U to say, hey, I gotta keep going, there's more here. And then I pick back up at 1 with a square bracket, and then I go all the way until 9 with that parenthesis. And we already talked about this example too here with all real numbers. Once again, that was from negative infinity to infinity, and we're always using what with those? Yeah, those parentheses, that open brackets. So we're going to talk about domain and range next, but this part right here, we're going to jump to after we talk about domain and range. So if you guys could flip to your next page. So domain. Woo! So domain, who remembers anything about that word domain from Algebra 1? What do you remember? It was a Nick? Yeah, it's your all possible x values. So it's the set of all input values that produce the output value. So it's your x values. So the one thing that we need to remember with domain is that it's your x values. We should all know that. So thinking about when I'm reading a graph, I'm going to be looking along the x-axis. So thinking about looking along the x-axis, that means if I'm starting at the smallest value, right? I always want to think about my smallest value first. On the x-axis, my smallest value is all the way to the left. So remember with your domain, you want to always go left to right. So think like along your x-axis. So always going left to right. So looking at this example here, I'm going all the way to the left. So I'm going to go to the very left point of my graph and then kind of think, where does my graph first start? At what x value? -4, right here. So think about this is my first x value right here at -4. So that's my first starting point in my notation. So what type of circle did we have here? Closed. I'm going to use that closed bracket. So I have -4. And then I'm going to travel along my graph to the right, because I'm going all the way left to the right. So if I'm traveling all the way to the right, I notice, yeah, my graph is hitting everywhere I'm going. And then I get all the way to the right here at the end, and I have this guy right here, which is an arrow. So what that means is this arrow means this graph is going to keep going this direction here. So remember, we're talking about domain. So with domain, it's left to right. So if I'm thinking right now about this arrow, what direction is it doing? It keeps going right, which means you're going to go all the way to what x value? Yes, positive infinity with a parenthesis. So now let's think about our range. So domain was your x, range is your y. Good. So it's your all possible, your y values. So think about range, then if it's your y values, you look along your y-axis. So if I'm looking along that y-axis, remember I'm starting all the way at my smallest value. So on my y-axis, if I'm starting all the way at my smallest value, that means I have to start looking at the bottom of my graph first, and then move and look all the way up to the top. So remember, you're going to look bottom to top. the bottom to top. So all the way starting at the bottom of our graph, this example here, if I put my pencil all the way at the bottom here, this is the first part of my graph that hits, which is this arrow. So remember, I'm talking about down and up. So this arrow here, we said it's going to keep going down, which means my starting value is, negative infinity. So I'm going all the way down. And then I'm going to travel along my graph and I'm going to go up. And I notice my graph ends here. So it ends at what y value? 5. So I'm going to go from negative infinity to 5 with a, what do we think 5 will have? Do we think it'll have a square or open? Square. Yeah, so it will have a square. So think about why it would have a square bracket here. Can you physically put your pencil on this point and say, yes, the output value there is 5? Yes. Yeah, so I'm saying, I guess the output value there is 5. 5 is included. All right, so that was our domain and our range. So let's kind of take a second and practice those. So going back to that page before. So we're going to do just a couple, we'll do like 4 together and then you guys can try 4 on your own. So looking at our domain, once again, remember that's your x and range is your y. So domain, remember I'm looking where to where? Left to right. So if I'm all the way at the left part of my graph, what's my first value? Negative 5 with a parenthesis. And then I go all the way until where? 3 with a square bracket. What about our range? What's that first value in our range if I'm going down, up? Yeah. Negative 4 with a, And then I'm going all the way up until 5. So note, just because this opened circle was here, when we're going up, think about this point right here is kind of saying that output is still included because there's still like a point that you can say that's the output. So let's kind of go over that again. We'll go over that again with this example here, but first let's do the one below it. So when in our previous example we had like a clear arrow. If you don't have a clear arrow, you're welcome to draw them in. If your graph goes to the end, if your function goes to the end of like the graph, that means it's going to keep going on and on and on and on. If you don't see it specifically end, and it goes to the end, that means it's going to keep going. So our domain, think about I'm going left to right still. So if I'm all the way at the left here, notice I have an arrow, which means this value here is going to keep going left and left and left. So it's my first value in that domain. Negative infinity. And then I'm going to travel along, and I go to the end here, and I also have an arrow, which means this is going to keep going like up and to the right. So I'm going to go all the way to the right, which means I'll go all the way to positive infinity. Anyone think they know what the range is here? Same thing. Yep, negative infinity to positive infinity. All right, so then let's jump back up to one of these like last top 2 we'll do together, and then you guys can do the other ones on your own. So this graph here has, I don't know how great the printing is on the paper. This graph has asymptotes, which is what we'll just show you that they like exist kind of today. Just know we won't really be getting fully into them with this unit. We'll get into it later. So your asymptotes are kind of parts where your domain and your range are not defined. So the asymptotes are there to say like this is where it's not defined. So thinking about that, what this vertical one, that was when x is equal to what value? Is that 2? Okay. So think about x equaling 2. That's your vertical asymptote right here, that line. So that line, this dotted line right here, is saying your x value cannot be 2. So let's keep that in mind while we're creating and saying our domain. So our domain, remember I'm starting all the way at the left here. I have my graph. What does this mean if it goes to the end right here? Yeah. Negative infinity is my starting point. So remember, now I'm going to travel to the right. So I'm traveling to the right, and I hit all the way up to this asymptote. So this line here is getting as close to 2 as it can, but never actually touching 2. So I'm going all the way from negative infinity until I get to 2, but I can't take on 2 at that value. So what do I need with 2 so I can't take it on? Yeah, the parentheses. And then, so I have my asymptote. I went all the way, basically I have to here covered, right? But I still have this other half of my graph. So think about here at my asymptote, I kind of have to jump over it and pick back up. So this means I'm going to have another interval. So I'm going to use that union to show I have another interval happening. And that other interval is going to start from right here. I get as close to 2 as I can. That's what's happening right here. I'm creeping up towards as close to 2 as I can without ever touching it. So that would mean I'm having another parenthesis with 2. I got as close to 2 as I can get. And then I'm going, looking to the right, and I'm traveling all the way to the right. So I'm going all the way to positive infinity. So think about this right here. This was that line x equaling 2. So what did we say? We basically said we wanted to show that x cannot be 2. This is how we are showing right here that x cannot equal 2. It's saying I get as close to 2 as I can on the left side. I can't quite touch 2. That's what my parentheses for. And then over here, this is saying I get as close as I can to 2 on the right side, but I can't quite touch 2. That's what that parentheses for there. And it's kind of, we won't be doing a lot with it right now, just know that. Just want to show you some examples of 2. Mm-hmm.
So we have these to be always in these parentheses.
Yes, good. Good. So your range, similar, but we're going to go down, up. So thinking about what's that y value right here that we're saying, like, y cannot equal? -1. So remember, this is this line right here, y equals -1. So if I'm going down, up, I start all the way at the bottom. What's that first value if it's going all the way down? Yeah. Negative infinity to, I get out, if I go up, I get super close to -1, but I don't touch it, so I go to -1 with that parenthesis. And remember, I had that asymptote, so I'm jumping over that asymptote, I'm picking right back up over top of it, and this was getting as close to -1 as it can. And then it was going all the way up, so it goes all the way up to infinity. We'll do this one next here together, and then you guys can do the rest of that page on your own. So, any questions before I keep going? All right, so our domain here for the this graph. Oh, does that look like square brackets? All right, so our domain, if I'm looking at this graph here, I'm going all the way to the left. So what's my first value on the left? -5, and I have a bracket here at -5. And then I travel along my graph and think I go all the way, this is the tricky part right here, right? So where is that, -1? So here, I'm going all the way to the right. So I travel along here, and I have this break in my graph. So does everybody see how I have a closed on top of an open? So this closed circle is kind of trumping this open circle. So this is saying at -1, do you have an input value there? Yeah, you do. I have an input at -1 right here. This is saying it's defined right there at -1 with that closed circle. This right here is going all the way close to -1 as I can, but then I'm like, oh, and then I touch -1 right here. So I'm getting all the way as close to -1 as I can, and then I touch -1 right here. So this graph is going to keep continuing with the domain all the way until, is that 5? With a parenthesis. So let's talk about the range, and then 1 second, I might answer your question. So talking about the range next, and then we'll do an example, and then if I don't answer your question, then please ask it. So for our range, we're going to go all the way down here at the bottom. So what's happening? We have an open and a closed circle at the same time. So remember that closed circle is going to trump that open, so we'll really use that square bracket here. And that's at -3. Sorry, I'm like, it's hard to see with the fuzziness. All right, and then as we travel up, your graph goes all the way until what y value? 5. With a square. So if you have something on your graph, and I'm sure you'll have an example like this later, but if you had something like this. So let's call this -1 here. We'll call this we're just going to talk about it in terms of the domain. We'll call this -3 here. We'll call this 1, and we'll call this +3. So if you were to say this domain, think about your starting here at -3, right, with that closed bracket. And then you travel all the way until -1 with that open. And then you're using your union to continue. And you would have 1 as your starting point next. Just +1 as your starting point next with that square bracket, all the way until 3 with that open bracket. So here, basically this is saying, with this point right here, with the notation, anywhere from -1 to 1, I don't have any input values, right? That makes sense if you're looking at your graph. Like 0, there's no input values happening. Was that your question?
My question was like if open circle was on top of the closed circle, would that make a difference?
Well, it's the same thing. Like if you ever have a closed and an open with each other at the same value, it's always going to, the closed circle is going to always overtake that open. But if this would be a totally different scenario if this was an open circle. So think about if that was an open circle, what your domain would kind of look like would be -5 all the way until -1 with a parenthesis, and then you would have to use that union to pick back up here and show from -1 to 5. So just know because of this closed circle was on top of it, we could continue. But if you had 2 open circles on top of each other, you can't continue. Yeah, and then you have to use that U. All right, so you guys are going to finish this page on your own, and then we can check it if you want to work with a neighbor. If you need any help, please wave me down. All right, everybody, so bring it back together. All right, so we're just going to quickly run through this second table right here. Do you guys want to start us off? One person want to do this first one for us?
Okay. Okay. The domain is parentheses 3
You mean
and
-3?
-3, sorry.
You're good.
And infinity with parentheses. And then it's parentheses negative infinity or parentheses.
Good. Guys, everybody okay with that one?
Yes.
All right, so let's jump down to the second row. Callie, will you give us our domain and range for that one?
Yeah, so the domain is open bracket and infinity, and then infinity, open bracket again.
Mm-hmm.
And then the range is the same thing.
Good. So kind of note that your domain and your range will be negative infinity plus infinity. If it can kind of go, if it kind of goes and extends over your graph like to the side and then like up and down. And then, sorry, want to give us the next one?
Okay, so the domain was an open bracket 0 and then infinity open bracket. And then the range was open bracket negative infinity and infinity.
Good. And then Nicole, want to give us the next one?
Open bracket, negative infinity, infinity, open bracket. And the range is open bracket, -2, infinity, open bracket.
Good. All right, did anybody have any questions on any of those? So let's keep moving back to that graphical characteristics page. So we covered domain and range, so now we're going to talk about increasing and decreasing. So thinking about just a graph in general, you're increasing when your graph is going like up, when you go from left to right. Remember, you're always kind of reading your graph left to right. And it's decreasing when it's going down left to right. So one thing that's important to remember with increasing and decreasing, you guys can all look at a graph and kind of put your finger and be like, yep, it's increasing here, yep, it's decreasing here. But one thing that you always have to remember is you always use your domain or the x value. So always use domain. When you're looking at a graph, you're going to kind of look to like where it's increasing, and then you want to just kind of intuitively look to your y-axis and be like, oh, yep, here's the top. But you actually have to look down to your x-axis because we're using our x values. And you always, always, always use parentheses, those open brackets. So those are two things with increasing and decreasing that we always need to remember to do. And then let's look at our example here. So if it helps you sometimes while you're first starting out with this, if you want to use like a highlighter or a different color pencil, that can sometimes be helpful in kind of highlighting where you're increasing and decreasing. So let's do increasing in red and kind of think, oh, yep, my graph is increasing from here to here. And it's, oh, shoot. All right, so we're going to go out towards the tennis court. So go out and then go to the right towards the trailer. So back to increasing and decreasing. So our increasing is in red, kind of that area just highlighted. So remember, I'm doing my x values. So think about, this was where we first started increasing, right? So I'm not looking over here to the y-axis. I look to my x-axis. So that means I'm going to go straight up and think, what is this first part? Is that at -3? Or is it like -2.5? Should we call it -2.5? It doesn't have to be perfect. So negative 2.5, and remember, I use what to show increasing and decreasing with my, yes, so parentheses. So I have a negative 2.5 is where I start increasing, and then I'm saying my increasing is going, my function's increasing all the way until here, which is like 1.5. So I'm increasing from this x value all the way to this x value. That's what we just showed right there. So let's talk about decreasing. So I first am decreasing here. So what's my first x value where I'm decreasing? -4. And remember, what do I use? Parentheses. Don't get caught up in the trick that it is a closed circle and you automatically want to think it's a bracket, but no, I have to remember I'm talking about increasing and decreasing, so it's a parenthesis, -4, and then we're going to go all the way until this x value here, which we call that -2.5. And then I'm also decreasing on this part of the graph too. So I have another part where I'm decreasing, so what do I use to show that I have another interval coming? Yeah, the U, the yin. For some reason, that's one thing no one will ever forget. So then we pick back up at that x value of 1.5, and we are decreasing all the way until what x value? So I heard some negatives and I heard some infinities. It is infinity, because think about, remember, it is your x value. So it's tricky because you're like, oh, my graph's going down because I'm decreasing. So you want to say negative infinity, but you have to remember I'm talking about my x value. So that means I'm going right and right and right forever. So that means I'm decreasing all the way until positive infinity. Oh. All right, so then a couple other pieces of information that should be a little familiar to us. So our x-intercept is the point where the function crosses what? The x-axis. Good. Does anybody remember those words that we sometimes also use for your x-intercept? Solution, I heard, was 1.
Zeros.
Good. Zeros. Does any, yes, I heard the last one it was? Roots. Good. So we have solution, zeros, roots. So it's going to always be in the form of an ordered pair, so x comma y. And note that if you're ever asked about a zero or what the zeros are, that is when we write x equals. So for an x-intercept, we want it as an ordered pair. For zeros, we want it as x equals that x value. So where are the x-intercepts from this graph up here? What is our first one we have? -4. So if I'm writing it as an ordered pair, -4, 0. What's our next one? We can just... And then what after that would be... looks good. All right, so your y-intercept is going to be the point where your graph crosses what? The y-axis. And we are always going to write y-intercepts as ordered pairs as well. So in that form, x comma y. So let's look at our graph to see where the y-intercept is. So where's our y-intercept? 3. So what is that as ordered pair? Good. All right, any other questions before we move on? Okay, so let's keep moving. All right, so end behavior is just describing basically what your graph is doing, kind of all the way to the right and all the way to the left. Like, kind of think about those arrows, right? When you have your arrows on the ends of your graph. So it's kind of saying, like, what's it really doing? So what this phrase is saying right here in question 1 is as. This is saying as x approaches infinity. So if I'm talking about infinity and x, does that mean I should be looking at the left or the right side of my graph? Right, so this means look at the right. So let's look at the right side of our graph. So I'm going to go all the way to the right side of my graph. And then here is where my end behavior is happening, because that's as right as my graph is going. So what's happening here? This graph is going in what direction? Down, which means it's going to what value? Negative infinity. So as my x goes to positive infinity, which means on the right side of my graph, all the way to the right, my y value, so that's what f of x means, my y value, my function, is going to negative infinity. That means it's going down. Now, looking at number 2, as, remember that arrow is meaning x approaches, so as x approaches negative infinity. So as x approaches negative infinity, what side of the graph should I be looking? Yes, so you're looking left. So looking at the left side of my graph, here is all the way to the left of my graph. I have this arrow, and this arrow is going in what direction? It's going up, so that means my function is going to go up to positive infinity. So if you have an arrow going down, that would mean negative. Arrow going up, positive. So if you don't, so let's go back to this. You guys don't have to, but just listen right here. So looking back at this graph here, if I'm talking about my end behavior on the left, so as x approaches negative infinity, I'm looking at the left. Do I have anything over here? Is my graph going anywhere? No, so that when that happens, I would just say like NA, like not applicable, nothing's happening. Because this graph has no end behavior because it's ending. I want to, like, with end behavior, I want to talk about where it's going. This is like, boom, it's done. It's not going anywhere. Solid point right here. But over here, you would say your graph's going to negative infinity. So you'll see that later. All right, so maximums and minimums are up next. So your maximum is the point with the highest y value. So when you're talking about maximums, that's when you want to look to where you're, we're only dealing with local or relative maximums in Algebra 2. So you want to talk about when your graph is going from increasing to decreasing. So think about your graph should be increasing, and then it should change to decreasing, and right there would be a maximum point. So where are the maximum points we have in this graph here? And I write them as ordered pairs. So we have one right here. What would this point be as an ordered pair? -1, and then what was the y? All right. And then we also have another maximum at this point right here, which is 3/8. So remember, we're relative or local max, so I'm looking for that change from increasing to decreasing. All right, so minimums, kind of the same, but obviously we want the lowest y value instead. So think about with your minimum, you want to know where it goes from decreasing to increasing. So think about graphically, I'm decreasing, and then I switch to increasing. So I'm looking for a point like there, like at that bottom point. So what are the relative minimum points we have on this graph? -4, 1, and what's another one? All right, so asymptotes we talked about earlier. Just know we're not super getting into them. It's kind of where your graph gets as close but never really touches. Just some examples down here. So what you guys are going to do next, just take a second and do the increasing and decreasing. Do we want to do one more increasing and decreasing together? Okay, we'll do this increasing and decreasing together, and then you guys will kind of be working on your own for the rest of the time. So let's talk first about increasing. So kind of if it helps you, if you put those points on your maximum and minimums, note that those are your turning points. That's when your graph is changing, either increasing or decreasing. So notice here, these x values that we have for those minimums and maximums, notice like those will kind of be what's in your intervals with your increasing and decreasing. So we'll do increasing first. If you kind of like to just move left to right, think first I'm decreasing, then I'm increasing. Do whatever strategy works best for you. I kind of like to just do increasing and then decreasing next. So I first am increasing from here to here, right? This was where to where? -4 to where? -1. So that's my first increasing interval. Was it positive or -1?
Negative.
Okay. And then I'm increasing again, so I need that union. Increasing again from here to here. So that is from where to where? Good. And then am I increasing anywhere else after that? No. So from 1, 2, 3. So now let's talk about decreasing. Looking all the way to the left. Where am I first decreasing? Yeah, -infinity to what? -4. Good, that x value. And then we will decrease again from -1 to 1. And then from, so from -1 to 1, and then we'll go from where to where lastly. So once again, kind of think about your minimum and your maximum, those x values, right? Notice where those appeared in your intervals. So think about your increasing, think about you have all these x values in your intervals. Does everybody see like the correlation? Also note that that graph, remember you had an arrow on the left and an arrow on the right. Your domain was -infinity to +infinity. So thinking about that, you should have every like value included. So if you ever want like a quick check, think you go from from -infinity to -4, and then I go from -4 to -1, -1 to 1, 1 to 3, 3 to infinity. I just covered it all. So that's kind of like a good check to know that you covered everything. Is your graph constant anywhere? Constant would mean like flat-lined. No. So constant would look something like if your graph was increasing, that flat-lined like this. All right, so because of that fire drill, we don't have super a lot of time left, but we still have plenty of time. We have 10 solid minutes.